All right, so the question is over the homework. It is 4x less than 5, right? Yeah, so this one's a little tricky because what we dealt with mostly last time, we had x's and y's in there, right? X's and y's. Here we only have an x. So let's first do the first step, which is to turn this into an equation, right? So let's turn this into an equation. 4x equals 5. And now let's try and figure out if this, what kind of line this is. Now normally we would look at this and we would say, okay, we can do intercept method or we can do y equals mx plus b, except for the fact we don't have a y. So there are two very special types of lines that we had that we have to pay attention to, and that's vertical and horizontal lines. In this case, if we divide both sides by 4, we get x is 5/4. Agreed? X equals 5/4 is either a vertical or horizontal line. You have to remember which one it is. Do you remember which one this is? Vertical. X equals a constant is a vertical line. Y equals a constant is a horizontal line. All right? So this right now, I know, is a vertical line that passes through what x value? 5/4. So I just go out, you don't even have to like mark down 1, 2, 3. Just know that 5/4 is to the right somewhere. And I know this is a vertical line. Now, am I going to draw this as a solid vertical line or a dotted vertical line? Dotted. And I'm going to do that because my original inequality there did not have the bar on the bottom, the equal. So I'm going to draw a dotted vertical line through 5/4, like this. And then I need to pick which side of this line I'm going to shade. And you can still do the same thing we did earlier. You can pick a test point. So how about picking the origin? Is that all right? Now 0, 0 means that x is 0 and y is 0. So try and plug in 0 for x into what? Where do I plug that 0 into? The original problem. So I'm going to plug it in up there at the 4x less than 5. So let me do that plugging in. I'll do it down here. What's 4 times 0? Well, not what is it, but 4 times 0 less than 5. Is that true? Yes, because 0 is less than 5. This is true. I'll put a check mark. It's true. That means that the origin point was part of our answers, which means I'm going to shade everything on that side. So I shade everything on that side of the line. Does that help? Okay. I just barely touched on those at the end of class last time. So I was expecting there might be a little confusion on those. So I'm glad you asked that. Okay. Let me remind everybody. Sure there weren't any questions here? No questions on this? No? Okay. Let me remind everyone that today we're going to finish up, what is it, 9.5, right? 9.5. We're going to finish 9.5, and then the plan is that Monday will be a review. We'll spend the whole day reviewing. And on Wednesday of next week, we will have our exam. Is that exam 3? Is it really? Wow. Exam 3. You only have one more exam after this, and that's the final. Now, I am considering doing something here. Depending on how things work out, the week of the 16th, we have 2 days for review for the final. I'm considering making one of those days a makeup exam day, where what you could do is, for everyone that day would kind of be an optional day, where you come in, if you want, and you can do a makeup exam on any of the previous 3 exams. So if you had an exam you didn't do well in that you want to retake, you can retake that exam that day. So I might have a couple of people taking exam 3 over, a couple of people taking exam 1, 2, just depends. All right? When we get there, we'll talk about it more, but that's kind of my plan. I think 2 full days for the final exam review might be overkill, but I don't want to jump the gun here. All right, so that's what you should expect next week. Remember, I've been allowing you to have a cheat sheet, right, on these exams. Same policy here, standard sheet of paper, front and back. You can write down steps, procedures, formulas. You may not have worked out problems, right? Okay, and I'll talk about that more Monday. All right, let's finish up 9.5. So for 9.5, what we've done so far is we've been able to graph a linear inequality in 2 variables, right? And what it turns out to be is shading part of the plane. Today what we do is we look at systems of linear inequalities in 2 variables. So now we're going to have 2 linear inequalities. We're going to have to do shading on both of them and then see what comes of it, right? So systems of linear inequalities, and I'll put here at the end 2 variables. There they are. Okay, so let's try this problem here. Y is greater than 1/2 x plus 1. X plus y is less than 1. All right, so remember the brace there on the left meant that we had a system. That means we're trying to find the x's and y's that make both of these true at the same time, right? Now, previously to this, when we were studying this, we had equal signs in there, didn't we? And so what we had was 2 lines, and we were trying to find where the lines intersected each other, weren't we? That's what we were trying to do. Because these are inequalities, we don't have, our answers aren't lines, they're shaded parts of the plane. So what we're looking for here is where our shaded parts overlap each other. Okay, we'll have to do these to kind of see what I'm talking about, but that's the idea. So the way we do this is pretty much the way that we just did the problem before. We turn everything into an equation first. All right, so let's first convert this system into a system of linear equations. All right, you see I changed the inequalities to equal signs. Now, this is something we've done before, right? So how would you solve this system of equations? What were your, well, there's technically 3 options. Does anyone remember what the 3 options are for solving a system of linear equations? Substitution, right? Addition, method, right? So we can do substitution, we can do addition, or I called it the elimination method, or the very first method we learned was just the graphing method, but we saw that the graphing method wasn't very accurate. So which method would you like to do here? Substitution or elimination? So this is where it's going to be up to you. Like, what are you most comfortable with, all right? Let's look at substitution if we chose that. If we did substitution, the steps were to solve either equation for one of the variables. Does that look like that would work out okay here? I could solve the first equation for y. It's already solved for y, isn't it? I could take that and plug it into this y and then solve that for x, couldn't I? So yes, substitution will work. If we do addition method or elimination, then we have to get all our x's on one side with the y's, and then all our numbers on the other side. Then we have to try and find that number to make things cancel, right? So we'll take a vote because I want to just do what I think most of you would do. How many of you would do substitution? Great. How many of you would do elimination? Yeah? Okay, we'll do substitution. Looks like we had more. So I'm going to use substitution here. And I'll put that here. Using substitution, we solve equation 1 for y. But that's already done, isn't it? That's why I chose equation 1 for y. So y equals 1/2 x plus 1. What do you do with that? Plug that into equation 2. So now substitute y equals 1/2 x plus 1 into equation 2. So here's what that'll look like. X plus, now what's y? 1/2 x plus 1. And then what's the rest of that equation? Equals 1. Okay, so I took that second equation right there. I replaced the y in there with this expression. So here it is. The rest of the equation's written out. Okay, now what? Try and solve for x, right? How would you like to solve for x here? Combine like terms? You want to put these two together? Anybody want to get rid of the fractions? Yes? Okay, let's clear fractions first. If I look at that, I don't like the fraction 1/2. What could I multiply both sides of the equation by to get rid of the fractions? 2, right? Multiply everything by 2. So I'm going to do the left side by 2, the right side by 2. I'll get 2x plus x plus 2 equals 2. That's just a little easier to work with without having to deal with fractions. Now, combining the like terms is a little easier, isn't it? 3x plus 2 equals 2. Now what? Subtract 2 from both sides. Good. So 0 equals 3x. Uh-oh. Now what? Divide both sides by 3. What's 0 divided by 3? 0. X is 0 is one of my answers. Now, what do you do with this answer? Plug that into the first equation. So substitute x equals 0 into equation, we should plug it into this one right here. Right? Remember when we had solved for y earlier? We had solved for y. So let's plug x equals 0 into that, and we would get what? Y equals 1/2 of 0, which is still 0, plus 1. So we get 1. So where do these two things hit each other? 0, 1. So we know that these two lines, right, hit each other at 0, 1. I mean, we're not even close to the final answer yet. Do y'all see that? As you'll see when we review on Monday, your test is going to really be reduced down to just probably couple of these problems. That's it. Because in this problem, you have to do everything we've done up to this point, don't you? So keep that in mind. So I'm going to go right now. I'm going to start looking at what my graph's going to be. All right. I'm just going to draw a rough graph here. I might have to redraw this whole entire thing, but I'm just going to start with a rough idea of what's going on. Okay, I know that these two lines hit each other at 0, 1, which is on the y-axis 1 unit up, right? That's where they hit. Y'all agree with that? Now, the equations that I had graphed, remember, that system of equations I had was y equals 1/2 x plus 1, and the other one was x plus y equals 1, right? That was the system where I got that answer from. Now, can you graph these two lines? Can you graph them? Well, how about y equals 1/2 x plus 1? Yes? Doesn't that look like y equals mx plus b? So let me graph that one. Well, no, I won't. How do I graph this? It should be just you looking at it to be able to graph it. What's the y-intercept? 1, which I already know that, right? Because they both hit right here. What's the slope of this line? 1/2. So that means I move from this point, I go up, how much? 1 to the right, 2. So if I draw another dot right here, that's part of this line, isn't it? Y'all still there? Okay. Now, if all I do is connect these two together, I will have that line, don't I? Now, should I draw it as a solid one or a dotted one? Dotted. Why? The original problem, go way back to the beginning, the original problem was an inequality, wasn't it? Inequality with no equal sign on it. So we call that a strict inequality. It's not ever equal. So that means when I draw this right now, I'm going to draw this as a dotted line through here. Do your best on the dotted line that you can do. Something like that. Can you graph the other line? Right here. Okay, yeah, how about moving the x over? So if I take this one right here, I move the x to the other side, it becomes negative x plus 1, doesn't it? That's just like y equals mx plus b. Here, what's our y-intercept? 1 again, right? What's our slope? Negative 1, right? Which is the same as negative 1 over 1. So that means I should go from this point right here on the y-axis, I should go down 1, that's the negative 1, and to the right 1. So down 1 to the right 1 puts me right there. Let me do it again. Down 1 to the right 1 puts me right there. It's that diagonal right there, just like this. Any questions? Solid or dotted? Dotted. Again, if you go back to the original problem, we had the strict inequality here, no equals, so I'm going to dot that. And I'm going to dot it right through where they hit each other, like that. We're almost there. We're almost there. Let's talk about this one right here. That corresponds to that first line up there, doesn't it? I would like to figure out which side of this line I need to shade. Do I shade the top of it or the bottom of it? Well, how do I do that? How do I figure that out? Test point, right? So what could we use as a test point for this one? 0, 0, right? Let me test 0, 0. And where am I going to test that point? The first, way back when, right? So I need to go back to this right here. And I need to test 0, 0. Test 0, 0 into that. And figure out if it turns out to be true. So let's see. Put 0 on the left. Is 0 bigger than, what's half of 0? 0. So 0 plus 1. Is 0 greater than 1? No. So that does not work. Agree? Since it does not work, I come back to this and I say, all right, well, this doesn't work. So that means this side of the line does not get shaded. So that means the other side does, right? So I'm going to shade, and I would do it real lightly here to begin, because this is not our final answer yet. We just know it's going to be this side, okay? That side of the line. Now let's try and, take just a deep breath here and remind ourselves of what this means. We're saying that to satisfy the original inequality, that first one from our system, we could pick any point up here, right? Any point in here should satisfy that first inequality. But what we need to be able to do is figure out what points satisfy both of them at the same time. So now we need to do the shading for this other line also. So how can we figure out which side to shade on this one? Pick a test point, plug it into the original problem. So I'm looking at this one right here. Which point can I use to test into this? You can use 0, 0 again, right? So I'm going to go back to that original inequality, which is here, and I'm going to test 0, 0. When I plug it in, I get 0 plus 0 is less than 1. Is that true? Oh, this one right here, I should have said this is false, right? Okay, this one is true. So that one did not work. This one does. So let me go back to my picture. The test point 0, 0 does work. We're talking about the blue one now, right? This blue one. So I will shade everything on that side of the blue, which means I'll shade everything on that side of the blue. Okay? We are pretty much there. We just have to recognize one more thing. Like I said, the whole idea of a system of linear inequalities in two variables is to figure out what points satisfy both inequalities at the same time. If I pick a point over here, here exaggerated, does that point satisfy the yellow one? No. Does it satisfy the blue one? No. So that couldn't work, right? What if I pick a point right there? Does that satisfy the yellow one? Yes. Does it satisfy the blue one? No, because the blue says this side of the blue, right? So that wouldn't work. How about down here? Does this satisfy the blue one? Yes. Does it satisfy the yellow one? No. So what we're looking for graphically is something over here where you're satisfying the blue one because you're below it, and you're satisfying the yellow one, which is above it. So won't it be everything here? So our final answer, final answer, is shaded this region like this. And remember, this line goes forever, doesn't it? And this line goes forever too, but our paper ends. So at some point we have to just stop. But the idea is that this pink continues out forever, right? You don't need to draw that, but just keep that in mind. It does go forever. So we have an infinite region which represents our solution. You do not have to show me this part and this part. Just this is what I want. But as you're doing the problem, you might want to put those. I'll show you kind of a slight other way to do the shading. Let me show you this. I'll just show you. I've seen it done this way, and I usually do it this way also in when I get to some classes that are a little bit higher than this, like business math. Oh man, we didn't really need that highlighted, but I'll just put it back. Okay, like remember we said for the yellow it was everything above, wasn't it? So in some other classes what I do is instead of drawing like the shading, what I do is I draw little arrows like this, saying it's everything above. And then for the other one it was everything below, like this. And so if you look at it this way, the two lines created 1, 2, 3, 4 regions, didn't it? And the region you're looking for is the one that has arrows pointing at, both arrows pointing at it. Like over here, the red points to it, but the green doesn't. Over here, the red doesn't, and the green doesn't. Here, the green does, but the red doesn't. Here, they both point to it. So you'd shade that. I'm just showing an alternative way of doing the same thing we've been doing. Any of you plan on taking business math? No? Math for business? No? Okay. This stuff is real. That course is really heavy in this stuff right here. These turn out to be like ways of finding optimum solutions to like cost and revenue functions and things like that. That there's an application to this, like real world stuff that goes with this. We're not going to touch it though. We're just going to be able to do the linear inequalities, the systems. All right. How about I show you one more and then give you one to work on? All right. Let's do I don't like that one. Let's do this one. Solve this system. We have a system of linear inequalities, right? Two variables. System of linear inequalities, two variables. All right, so what we did last time, if we try and summarize what we did last time, we found the point they intersected, right? Then we drew the lines, and we either drew them are dotted or solid, depending on this right here. Then we determined which side of the lines to shade. And then we found out where they overlapped, right? So let's follow that same process again. We're going to first find where they intersect. So I'm going to turn them into equations to start. Hey, just a question to you. At this point, can you tell me if the lines are dotted or solid? Yes. I can tell you that this first one is going to be what? Dotted, and the second one's going to be a solid line. And I'm doing that by just the difference in the inequalities. Okay, so turn it into an equation first. System of equations, sorry. And then sit there and look at it and decide for yourself what technique you'd want to use. Elimination. Okay, if you're going to do elimination, what variable would you like to get rid of? You could do X or Y, right? How many of you would do the X? A lot of people do the X because that's just like the standard. You just always want to go after X if that's the way your brain wants to do it. The Y would probably be easier because the Y, all they're off by is a sign, right? But, okay, so can we vote again or not? X's? Who wants to kill off the X's? Be afraid. I'm shy. Okay, how about the Y's? Wow, I'm surprised to see that. I really am. Okay, because I didn't feel like I stressed it enough that you have the freedom to do it either way, but you do. So I'm going to go with the y's. The y's win it on that one. Okay, if I want to eliminate the y's, one of them is the top one is a 1y, right? The bottom one is a 1y. So I just need those to be different in sign. I need one to be positive, one to be negative. So all I'm going to do is just pick which equation do I want to multiply by -1. Your choice. I don't care. Top one? Okay, -1 across the top. It's going to go through and change the signs of everything. So when I do that, my new system becomes -x, -y equals -4. The bottom equation does not change. What do you do now? What do you do now? Add down, right? Add straight down. Okay, so let's add. We get -x and add 3x and you get 2x, right? The y's cancel. What's -4 plus 9? 5? Can you solve that for x? Divide by 2, both sides, and x is 5/2. Which if on your calculator you did that, that'd be 2.5. You can do it either way. The thing is you're going to have to be able to know where this point is to graph it. So unless you know exactly where 5/2 is, you'll use your calculator to get that as a decimal. All right, what do we do now? Take that and do what with it? Plug it into any equation we want. We can do it on this one, or we can do it on this one. We are not touching this right now, right? We're kind of working our own stuff over here. These are equations. We're working with equations only right now. We only refer back to this when we want to know if it's dotted or solid lines and when we want to test our points. Other than that, we're going to work with the equations instead. Any of these, any of the ones that have x and y in it. I personally like that first one up there. This one right here, before we changed it, x plus y equals 4 is what it was. That's what I'm going to choose to go into. So I'm plug that into the x plus y equals 4. I'm replacing x with, you want to go 5/2 or you want to go 2.5? 5/2? Ooh, you want the fractions? What the hell's going on here? Is it opposite day or what? Opposite day. Yeah, fraction appreciation day. I like that. Yes. What do we do? What do we do now? Oh, okay. You want to get rid of the fractions? We can do that. Is that okay with everyone? So I'll multiply everything by 2. That'll give me 5 plus 2y equals 8. Now what? Subtract 5 on both sides, so you get 2y equals 3, right? And that means y is equal to, dividing by 2 on both sides, 3/2 equals 1.5. I'm going to pause the video because this isn't really appropriate what I'm about. Interesting. All right. Oh, I changed it to a decimal, right? Again, because that's going to help me graph it. What's the next thing we did after we did that? We started a graph, right? So let's go ahead and start a graph. All right. Whoa. The point we're trying to plot, what was x? 2.5? And y turned out to be 1.5. So if I'm counting by, let's see, 1, 2, 3, if each of these little, what we call tick marks is 1, then we've got 1, here's 2, 2.5, and then up 1.5. Shouldn't that put me right there? Do you agree with that? That's 2.5 to the right, or 2.5 to the right, and 1.5 up. What is that point again? What does that point represent? Where those two lines hit each other, right? Where they hit each other. What would be really nice is if we actually had the lines now, right? So that's what we should go do next. We should try and get those lines. And remember, what we're working with here was x plus y equals 4, and the other one was 3x plus y equals 9. Right? Anybody want to tell me how they're going to graph that first line? Oh, you want to do intercept method on that one? I like that idea. How would you find the intercepts on this one right here, x plus y equals 4? How would you find the x-intercept? Set y equal to 0. Okay? So to find the x-intercept here, I set y equal to 0, and that gives me x equals 4, doesn't it? If y is 0 in that equation, x is 4. And that's quick and easy, isn't it, that way? So if I go there, I get x is 4. That puts me here. See my dot? I just put it there. What's the y-intercept? Same thing, right? Y-intercept. This time you set x to 0. That tells you that y is 4. So that puts me up here. Now, I actually didn't need another point because I already had another point, didn't I? Isn't that point that we put 2.5, 1.5, doesn't that point live on both lines? So I didn't have to have another one, but hey, it didn't hurt to put it there. Now I'm going to draw a line. Is it going to be solid or is it going to be dashed? Dashed or dotted, right? And that's because in the original problem here, up here, top left, going back to the idea of the inequality, it's a less than, strictly less than. So no equal sign underneath that less than sign. So I will put a dashed line. Oh, man. What would you like to do now? For the other line, how would you like to address that? You want to do intercepts again? I'll do this one over here towards the top left of the page here. Maybe not that far. I'm going to try and do the 3x plus y equals 9. If I'm going to do that, then you're saying intercept method again? That's okay with me. If we're trying to find the x-intercept, what do? We set y equal to 0. If y is 0 there, we get 3x equals 9, which means x is what? 3? Now I'll do this one in a different color. X is 3. That's the x-intercept. See where I put it right there? And now you want to do y-intercept? Y-intercept, you set x to 0, and you get y is what? 9. And then I go, damn it, I don't have enough room, right? 9's off my graph. But it's pretty far up there, isn't it? Now, remember I said that this point right here is the point that they both hit, right? So really, I could just do this point to this point and draw a line through them, and that would be sufficient, right? I know that it hits way up here off my page, but if I draw a line that goes like this and this and then just keeps going and then stops up here, put an arrow on it, that would be good enough. If not, your only other option is to do this. Magically create more space on your page, like I just did, and then extend your line up. You see, but or redraw your whole graph, however you want to do it. I'm just going to connect the two, because I think that's what you would do, right? Maybe not. Oh, solid or dashed? Ooh, I forgot. It's solid this time, because the original inequality had the equal under it. So I'm going to try and connect these. That all right? All right, shading time. What's a good test point for both of these? 0, 0, right? So I'll be able to test 0, 0 again. Let's test 0, 0 into the first inequality. I think I'll be able to do that under here. The first inequality was x plus y was less than 4, right? Plug 0, 0 into this, and you get zeros less than 4. What does that tell you? Zero is less than 4, right? This is true. Which means that I'm going to shade which side of which line? What's that? The bottom of which one? The dash, because this x plus y less than 4 was the dashed one, right? So I want everything on this side of it. Now, do y'all want to do the shading, or did y'all like the arrows? Y'all like the arrows? Okay. Yeah, y'all are all full of surprises today. Everything I think you are wanting to do the opposite. You don't want to have a quiz today, right? So you're going to agree with me on that one, right? All right. See how you are. Yeah, we're ready for a closed book exam over everything we've done this semester, right now. All right, test that point into the second inequality, which is the one that's the solid. And that one is, I'm going to need a little more room here. It was 3x plus y less than 9, and that's 0 less than 9, isn't it? And that's true also. So that means I will shade everything on which side? Here it's not really top and bottom, it's more kind of left and right, isn't it? So I'm going to be on the left side of that line. So it's everything over here. Now, we have 4 regions, don't we? Let's see, this big region over here, I'm talking about this, all this stuff over here. Is that our answer? No, because the arrows are pointed away from that region, right? So it's not that. We have this region right here. Well, the black arrows here are pointed at it, but these red ones here are pointed away. So it's not that one, right? And then over here, the black ones are pointed at it, but the red ones are pointed at it, but the black ones are pointed away. So that's not it. And the only region left is everything over here, right? Everything in there. And I've got arrows pointing towards it on both the lines. So that's the answer, everything over there. And of course, you can make it however fancy you want to make it. You want to shade that all in, get out your art pencils or whatever. Okay, so look, I did 2 problems, right, in class today, and it's 10:20 right now. That gives you an idea of how long these problems are, and that hopefully kind of gives you an idea that the test, right, the exam, it would make no sense for me to ask you to solve a system of equations on the exam if I'm going to ask you one of these, because in this problem you have to solve a system of equations, don't you? So I can kill like 10 birds with 1 stone with this problem. So that's what I would expect. Let's have you try one. I'm going to count it as a quiz grade, but it's going to be more like an effort grade. If you get to the answer, you're free to go. And I'll put the homework assignment up. So in class quiz is just this problem. I'm not going to pick it up, but I am going to check it to see that you have done it and completed it. I might just make one up here. X plus 2y is greater than 4. Thinking, hold on. There you go. Enjoy. Help each other out, okay? Talk through it with your neighbor. Pardon? Attendance, yes. Well, I'm going to take it kind of on the quiz. That's what I'm doing. I'm going to come around. I'm going to check you off on your attendance for your quiz grade. Oh, you can use everything that we've used today, all right? This is just an exercise. I'm counting it as a quiz grade, but it's an exercise. Talk to each other if you need to. Ask me questions. So there's only 2 problems for homework. Right there.